Hello! Today we are coming to you live from Math Lab. And as you can already tell, the Bambino is definitely here. And hopefully he won't be a complete distraction to the whole world. We got the yummy kitty snacks. So hopefully shut him up. Awesome. Let's see how long that works. So, today we're talking about factoring trinomials. We have already factored out binomials. We learned that in the last lessons. I do want to warn you right now that my method for factoring is completely and utterly different than the books. So if you look in the book for examples for help, it's going to totally confuse you. So do not look at the book for that. But my factoring technique uses this little plus sign, this little grid here. It's got 4 quadrants. And for this lesson, you will be happy to know that you will always be placing a 1 and a 1 on the left of this quadrant. And you see these little arrows that are going here? Those are like directions to tell you what to do. You are supposed to be looking for factors of C. So again, we're talking about quadratics that have a C over here. So factors of C will go here and here. Decian. And after you have picked those 2 numbers, you will multiply diagonals. So you'll see these green lines drawn here. Those are the diagonals. So I have to add the product of diagonals. So I multiply these 2, multiply those 2, then add them together. And that number should equal B. Once you've gotten that puzzle to work, then you're pretty much done. So that probably didn't make any sense to you right now, but we're going to try it with an example. I have over here x squared plus 7x plus 12. So in my case, my C value is 12. And so I am looking for factors of 12. Numbers, 2 numbers that multiply to get 12. I could use 12 and 1. I could use 6 and 2. And I could use 3 and 4. Those are all factors of 12. And I'm pretty sure that's all of them. So if I put 12 and 1 here, I will quickly find out that that's not the way to go, because if I multiply this diagonal, I get 12, and multiply that diagonal, I get 1, and 12 plus 1 is 13, and B is 7. My B value is 7, so it doesn't add up to 7. So that tells me not to use 12 and 1, and then I can try to use 6 and 2, but same problem, 6 plus 2 is 8, not 7, and by now you're probably like pretty clever, and you know that the real answer should have been 3 and 4. If I choose the factors 3 and 4, then 3 plus 4 is 7, and 7 is the B value. So once I have this quadrant filled in, this is basically my answer. This side is the variable, and this side has no variable most of the time. So my final answer will be going across. Okay, that should have been blue. Not sure why it's still red. Seriously? Blue. Blue! OMG. Not really a smart board, but it doesn't do what I tell it to. Okay, so the variable in this case is x. So I'm going to go this direction. So my answer is not x plus 1. It's 1x plus 3. So I write over here x plus 3. My second factor is 1x plus 4. So I get x plus 4. And now this quadratic, this trinomial, is said to be factored. If you're wondering if that's true or not, you can check your work by going backwards. We have already learned how to FOIL. First times first, outside times outside, inside, inside, last, last. So, first times first, x squared. Outside times outside, positive 4x. Inside times inside, positive 3x. And last times last is positive 12. Which is in fact x squared plus 7x plus 12. So when I multiply it back, when I FOIL back, I get the exact same problem that I had to begin with. Okay, this is just checking your work, but this is the actual answer right here. So now, Orlando, who happens to be in Math Lab today, woot woot, is going to come up here and show you how to do A from the do-it-yourself one. And then you guys can do B and C at home. Awesome! Already off to a great start. Orlando's shy, so he doesn't want to tell you what he's doing, but it's okay.
I don't even want to do it.
Good job. Desian's doing great. Orlando's doing great. Awesome. Thank you. So as you can see, the 1, the factors of 10, 5 and 2, diagonals, 5 plus 2 is 7. That's 7, so it works. The answer is across, x plus 5, x plus 2, bam, perfection. So now you can try B and C at home. And now I'm going to go on to this little guy. Again, the factoring technique and all of these is going to be the same. It's just going to get trickier when you're trying to have, when you have like negatives. The first example I showed you were all positives. So now we want negatives. So again, we're going to put 1, 1 here. And I'm looking for factors of 42. OMG. So I'm pretty sure that it could be, what is it, 5 times 6? That's wrong. What is it? 6 times 7. Where's my eraser? Sorry. La 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 la. 6 times 7. What else? 21 and 2. Isn't 21 times 2 42? Yep. What else?
3 times
3 times 14. Alrighty. So those are some options. But remember, we wanted to add up to negative 17. Negative 17. In order to get a negative, it means that when you add the two numbers together, the larger one has to be negative, right? So I'm looking at 6 and 7, and no matter what you do, they're not going to add to 17. 21 minus 2 is 19. So that's not going to do anything. But this one might work. 14 and 3, that could be 17. So I'm going to try those. And to get a negative here, they both have to be negative. Okay, so if I have negative 3 times negative 14, that'll be positive 42. And then when I go to my diagonals, negative 3 and negative 14 is plus negative 14 is negative 17. So that works. So this is my correct little problem here. Desian. And we're going to get x minus 3, because we'll go across with my answer, and x minus 14. And this time I'm not going to check my work, but I'm pretty confident that it's right. And now, Jin Young, yeah, she grades your homework, you know, that one, you can yell at her later. She's going to come up here and do A for you. They're going to grade you now on how well you did your example. Meanwhile, we're going to give you some food.
5 times 5. Go across. But then it's negative 10, so you go negative, negative. It's negative 5. It's negative 10. Becomes x minus 5.
Ooh, look at you, get all fancy schmancy. Good job. Okay, so yep, we have negative 5 and negative 5 is negative 10, so that works. And going across, and because they're the exact same factor, she did square. You don't have to do that, but that's kind of cool. She's all showing off with it. Anyway, so, and then we have this little guy. And again, same process, but now we have, this guy's negative. So 1, 1. I need factors of 27, like, I don't know, what's 9 times 3? 27. Yay. I'm going to pick 9 and 3, but I need it to be a positive 6. When you have a negative C value, one of these two numbers has to be negative and one has to be positive. It's the only way to get a negative when you're multiplying. And I should say that when you're over here, to get a positive C value, both of these have to be negative, or both of them have to be positive. Like in this case, both negatives make it positive. In my first example, we had plus 10, both positive. If you have a positive C value, then the factors have to have the same sign. But when you have a negative C value, the factors have to have opposite sign. So the question becomes, do I make the 3 negative or the 9 negative? But you want a positive 6, so the smaller number should be negative. So that when I go 9, and I add negative 3, I get positive 6. If I reverse it, I'll get negative 6, and you don't want to get a negative 6. So once I complete that guy, my answer will be x plus 9, x minus 3. And I'll show you over here, I'm like all up in Leonard's face. Leonard doesn't even know that, you don't even know Leonard's here. They can't see you, by the way. They can only see up to the board, so you're like totally out of the picture. Well, now his hand's in the way. Okay, so factors of 18. Factors of 18 that will add up to 3. Again, I could do 9 and 2, but 9 and 2 won't add up to 3. So I should pick 6 and 3. Right, Jinya? 6 and 3 will give me 18. And 1 has to be negative. So if I want this to end up being a negative number here, then I should make this negative 6. So that when I go negative 6 plus 3, I'll get negative 3, because the 6 is bigger. So then that will give me the right values there, and I'll go, oops, my variable this time, bad, it's not an x, it's a p, so p minus 6 and p plus 3. And that'll be the answer for that little bag. And by the way, I've been so bad. This is an M. This should be an M and an M. Sorry. All right, and then you guys can try these ones. And this is the last example I want to show you. It's an example that has 2 variables, h and k. So, but have no fear. For the most part, you could ignore the 2 variables situation and just deal with the numbers. 1, negative 4, and negative 77. So I need factors of negative 77, and that is just an ugly number. What are they going to be?
11 times 7.
11 times 7? Sounds like a plan to me. All right, let's try 11 and 7. And one of them has to be negative, so since this is a negative 4, the bigger number should be negative. So that when I add them together, I will get negative 11 plus 7 is negative 4, which is that right there. And this time, because you have 2 variables, you just put h here and k there. So this will be 1h minus 11k. And then this will be 1h plus 7k. And there's your answer. So it doesn't really change the problem other than you have to put 2 variables at the end of your answer. And so then you can try these guys. And once you've done that, you've completed your lesson for today. And I will see you in class, whatever that is. Tomorrow, next year, who knows?
Next month.
Where's the, hi. Oh, there it is.